A $100 million test site gets obliterated by an explosion. Most companies would shut down for months. But SpaceX? They just turned their broken launch mount into a genius test stand in weeks. How is this even possible? While competitors file insurance claims, SpaceX is already preparing Ship 37 for static fire using this wild improvised setup that shouldn't work, but does. Let's dive right in. January 12th, 2025. Ship 36 was just another routine test at SpaceX's Massey facility, until it wasn't. Without warning, a composite overwrapped pressure vessel deep inside the nose cone ruptured with devastating force. The explosion was so violent it launched metal debris hundreds of feet into the air and turned a $100 million facility into a smoking crater. But here's what nobody expected. This COPV failed at 60% of its rated pressure. That's like a car tire exploding when you're only halfway done inflating it. Something was fundamentally wrong, and SpaceX had no idea what. Within hours, the damage assessment was brutal. Pumps destroyed, vaporizers obliterated, heat exchangers twisted into unrecognizable metal sculptures. Any rational company would be looking at 6 to 12 months of downtime and insurance claims. SpaceX isn't rational, they're relentless. While recovery crews were still clearing debris, SpaceX engineers were already breaking every rule in the aerospace playbook. Their solution? Convert their orbital launch mount, a structure designed to hold and launch rockets, into a makeshift test stand for Starship. Think about the audacity of this idea. It's like deciding to turn a Formula One racetrack into a car assembly line. The orbital launch mount was built for super heavy boosters, weighing 3,400 tons. Starship weighs 1,320 tons. Different fuel pressures, different flow rates, completely different everything. But SpaceX saw opportunity where others saw impossibility. They had a functional launch mount and desperate deadlines to meet. The question wasn't if it would work, it was how fast they could make it work. Step 1, rip out every booster hold-down clamp. These massive mechanical arms were designed to grip super heavy during fueling and launch, but they just get in the way of Starship testing. Picture surgeons removing a patient's rib cage to access the heart. That's the level of structural modification we're talking about. Step 2, install completely incompatible fuel systems. Starship uses different quick disconnect systems than Super Heavy. It's like trying to fuel a Tesla at a diesel truck station. The connections literally don't match. SpaceX engineers were spotted building a brand new Starship-specific quick disconnect unit from scratch. This isn't an adapter. It's a completely custom system that has to handle liquid methane at negative 162 degrees Celsius, liquid oxygen at negative 183 degrees Celsius, plus nitrogen purge and high-pressure helium, all while maintaining flow rates precise to the liter per second. One miscalculation means either starving the engines of fuel or overpressurizing the tanks. Both end very badly. Here's what most people miss. Changing the hardware is only half the battle. The computer controlling these systems needed a complete personality transplant. Starship has smaller tanks and tighter pressure margins than Super Heavy. The timing for valve operations, pump speeds, and flow regulation is completely different. The software team essentially had to create a new brain for the launch mount that could think like a Starship instead of a Super Heavy. Recent venting activity suggests they're already testing this new digital nervous system. Every puff of gas you see is actually the computer learning Starship's unique personality. It's machine learning in real time, with explosive consequences if it gets things wrong. While the Massey crisis unfolded, something extraordinary was happening inside Gigabay. SpaceX was installing the most significant upgrade to Super Heavy since the program began. A massive 40-meter transfer tube that's about to revolutionize everything. This isn't just any pipe. At nearly the length of an entire Falcon 9 rocket, this tube has to survive forces that would crush normal equipment. Elon Musk called it very buff because a single leak would be game over. But why build something so extreme when the old system worked? The answer lies in a problem that's been silently sabotaging SpaceX missions. Propellant sloshing. During stage separation, when the booster and ship split apart, chaos erupts inside the fuel tanks. G-forces shift violently, engines shut down, the vehicle flips, and the fuel goes absolutely crazy. Picture a washing machine filled with gasoline during an earthquake. That's what's happening inside those tanks. Previous designs used small header tanks floating inside the main tanks. But here's the nightmare scenario. When SpaceX fires up the new Raptor 5-3 engines with 25% more thrust, and Block 3 ships carry 3 additional engines, the sloshing gets exponentially worse. The fuel becomes so turbulent that engines can't restart reliably. For a Mars mission lasting months with multiple engine restarts required, this isn't just a problem, it's mission killing. SpaceX's solution is brilliant in its simplicity. Instead of fighting the sloshing, they bypassed it entirely. The new 40-meter transfer tube isn't just a pipe, it's essentially a series of header tanks integrated into one massive structure. These tanks store clean, stable fuel completely isolated from the chaotic main tanks. When the booster needs to perform its boost-back burn to return to the launch site, it draws fuel from these stable header tanks instead of the sloshing main tanks. It's like having a backup fuel system that's always ready no matter what's happening in the rest of the vehicle. But installing this monster tube required precision that defies belief. We're talking about tolerances measured in millimeters on a structure that's 40 meters long and weighs several tons. One alignment error and months of work becomes expensive scrap metal. Ship 37 sits in Gigabay 2, fully loaded with both sea-level and vacuum Raptor engines. This vehicle is about to become the first Starship to test on a converted orbital launch mount. If successful, it'll pair with Booster 16 for Flight 10. But here's where the scheduling gets interesting. Ship 38 is taking a different path, undergoing cryoproof testing first. This is essentially a freeze torture test where the vehicle gets filled with liquid oxygen and methane to verify every tank and system can handle the extreme cold without cracking. The pairing system reveals SpaceX's confidence levels. Ship 38 will launch with Booster 15, the same vehicle successfully caught during Flight 8. Since Booster 15 is flight-proven, it needs minimal testing. But there's a catch. The launch mount has to be reconfigured back to booster mode before Booster 15 can do its static fire test. This creates a fascinating logistical puzzle. SpaceX has to orchestrate ship testing, mount reconfiguration, and booster testing like a complex ballet where one wrong move derails everything. While solving immediate problems, SpaceX is simultaneously building tomorrow's solution. The Gigabay integration facility has moved from foundation work to actual construction, with massive piles driven deep into Texas soil to support what will become a manufacturing monster. This isn't just another assembly building. Gigabay is designed to produce over 1,000 Starships annually, nearly 3 vehicles every single day. The automation and efficiency required to hit those numbers represents a fundamental reimagining of how rockets are built. A parallel facility under construction at Kennedy Space Center will support East Coast operations from Pad 39A. The two-coast strategy ensures that no single disaster can shut down Starship production entirely. Not every SpaceX plan survives contact with reality. The U.S. Air Force just canceled plans for Starship landing pads on Johnston Atoll, a remote Pacific island that was supposed to demonstrate global cargo delivery. Environmental concerns killed the plan after nearly 4,000 petitioners warned that rocket landings could devastate wildlife habitats, supporting over 1.5 million seabirds. The cancellation represents more than just a setback. It's a preview of the environmental and political battles SpaceX will face as they expand globally. Every new launch site will face similar scrutiny. What makes SpaceX's approach fundamentally different? While other aerospace companies would see the Massey explosion as requiring months of investigation and careful reconstruction, SpaceX sees it as a problem to solve creatively and immediately. This philosophy permeates everything they do. The 40-meter transfer tube isn't just solving today's sloshing problem. It's preparing for future challenges with more powerful engines. The orbital launch mount conversion isn't just a workaround. It's proof that SpaceX can adapt any system to meet their needs immediately. The rapid Gigabay construction isn't just about meeting production targets. It's about fundamentally changing how rockets are manufactured, moving from artisanal craftsmanship to true mass production. All of this is happening under crushing time pressure. SpaceX has committed to multiple launches in 2025, and any significant delay cascades through their entire manifest. The Massey explosion could have derailed the program for months. Instead, by the time Massey is rebuilt, SpaceX will have operational experience with multiple types of test facilities. They'll have learned how to test Starships on dedicated test stands and converted launch mounts. This redundancy makes the entire program more resilient. What started as a disaster has become SpaceX's latest demonstration that they can turn any setback into an opportunity for innovation. The orbital launch mount conversion should be impossible, but Ship 37 is already preparing for its test campaign. The 40-meter transfer tube should be too complex and risky for a startup rocket company, but it's already installed and ready for Block 3 testing. The Gigabay production rates should be fantasy, but construction proceeds on schedule. This is SpaceX's true genius, making the impossible look routine while simultaneously pushing the boundaries of what's possible even further. The Massey explosion didn't slow them down. It accelerated their innovation timeline. So here's what we just witnessed. SpaceX didn't just solve a crisis. They redefined what's possible in aerospace engineering, from a catastrophic explosion to a working test stand in weeks, from sloshing fuel problems to a 40-meter engineering marvel, from production bottlenecks to 1,000-vehicle factories. But this raises a bigger question. If SpaceX can turn their worst disaster into their greatest innovation breakthrough, what happens when they face the real challenges of Mars? When every system failure is literally life or death, and there's no Earth-based backup plan, the techniques they're perfecting right now, the rapid adaptation, the impossible timelines, the willingness to break every conventional rule. These aren't just about getting to orbit faster. They're rehearsals for humanity's greatest adventure. What engineering impossible do you think SpaceX will tackle next? And are we ready for a world where the impossible becomes routine? Let me know what you think down below. And if you want to stay ahead of every SpaceX breakthrough as it happens, make sure you're subscribed to Space Core. Because the future isn't coming, it's already here. This is Dreamchaser. This is SpaceX Dragon. Both can carry astronauts to space. But how is it possible that this lands like a fighter jet on any runway, while this crashes into the ocean like a meteor? And why did NASA choose the ocean crasher over the runway glider? Most importantly, what makes Dreamchaser's runway landing so revolutionary that it's about to humiliate SpaceX's entire approach? This is the story of how Sierra Space turned aviation dreams into space reality. Let's dive right in. Picture this. 3 companies walk into NASA's headquarters. 2 leave with billion-dollar contracts. 1 gets shown the door. That rejected company, Sierra Space with their Dreamchaser, their crime, building a spacecraft that was too advanced for NASA's comfort. But here's the twist nobody saw coming. The 2 winners, SpaceX and Boeing, just gave Dreamchaser the ultimate revenge opportunity. Boeing's Starliner is grounded indefinitely. SpaceX's Dragon? It's about to look like a relic from the Stone Age. Why? Because Dreamchaser is finally ready to fly. And when it does, it's going to humiliate every capsule that ever touched water. Let me paint you a picture of what happens when Dragon lands. This 15,000-pound capsule slams into the Pacific Ocean at 17 miles per hour. That's like dropping a car from a 3-story building. The impact alone destroys delicate experiments worth millions of dollars. But that's just the beginning of Dragon's nightmare. Salt water. The moment Dragon hits the ocean, corrosive salt starts eating away at everything. Electronics that cost more than a house become scrap metal in minutes. NASA recovery teams race against time, but the damage is already done. Now watch Dreamchaser land. It glides down like a fighter jet, touches the runway softer than a commercial airliner, and rolls to a stop. No violent impact, no saltwater bath, no race against the clock. Dragon returns cargo destroyed. Dreamchaser returns it perfect. Which would you trust with your life's work? Here's what SpaceX's marketing team hopes you never discover. Dragon's pressurized volume, 9.3 cubic meters. That's smaller than most walk-in closets. Dreamchaser's pressurized volume, 33 cubic meters, nearly 4 times bigger. But wait, SpaceX will tell you Dragon has more space because of the unpressurized trunk. That's like saying a pickup truck has massive cargo space because of the truck bed. Sure, you can haul lumber, but try transporting anything that needs climate control. Dreamchaser's 33 cubic meters are all pressurized, all temperature controlled, all perfect for the kind of experiments that actually matter. Here's another number SpaceX buries. Dragon can only dock at one location on the International Space Station. Dreamchaser can dock at multiple ports because of its superior docking mechanism.